Hello everyone. Today we are diving into the fascinating world of circuit geometry. So whether you're prepping for exams or just want to strengthen your understanding of this topic, circles, this video is for you. Let's get started. Before we dive into solving problems, it's essential to familiarize ourselves with some basic terms related to circles. So this is a circle with center C. The center of a circle is the point that is equidistant from all points of the circle. So that means this point C is equidistant, that is, it is the same distance from any point on the circle. So let's draw a line from the circle to the center of the circle. And let me draw another one. I'm using different color. I'm using red and blue from the center to any part on the circle. Now, I want to measure this line just to show you that the center of the circle is equidistant from any point on the circle. So, measuring the red point, this is about 5.2 centimeter, right? Then measuring the blue line, this is about 5.2 centimeter too, right? So this proves that the center is equidistant from any point on a circle. The circumference of a circle is the distance around the circle. It is the distance around the circle. It is also called the perimeter of the circle, right? So now, before going into the formula to calculate circumference of a circle and all that, let's us define other terms of a circle, right? The next term we're talking about is the radius of a circle. The radius of the circle is the distance from the center of the circle to any point on the circle. Now, these red and blue lines we drew, they are both radii. That is, a radius is a line drawn from the center of the circle to any point on the circumference. This is what a radius, right? So therefore, since I explained in the past term about centers that it is equidistant from any point on the circle, right? It means what we calculated, what I measured that we got 5.2 centimeter was the radius. That means the radius of a circle should be the same. No matter how you draw the line, if it is like this, or like this, or like this, you should have the same answer because they are all radii. Talking about a chord. So a chord is a line with both ends on a circle. Like this is a chord. This is another chord. This is another chord. This is another chord. So chords are basically straight lines with both ends on a circle, right? Now, a diameter is also a chord. It is a special chord that passes through the center of the circle. I'll be using a blue line to represent the diameter. It is a special chord that passes through the center of the circle. So it can be like this or slants or even horizontal. Do you understand? So the diameter is also a chord. Very, very simple. In the next thing we're talking about is the arc. An arc. I'm sure we've heard of that before. So an arc is a part of the circumference. For example, if let's say this is a pizza and I cut out this piece, right? So these parts I'll be highlighting with green is called an arc. It is a part of the circumference. Then a sector is a region, like I said, a region or a part bounded by two radii. This is a radius, right? This is another radius. So it is a region or a part of the circle, like bringing out that pizza out, right? That pizza, like this. So this is what they call a sector. A sector. So please don't mind my drawing. Let me just shade it in the circle. So this is a sector. Sector. And then what we call segments. A segment is just the part bounded by a chord. For example, this is a chord, right? So this part is a segment. These other parts, the remaining part is what? Also a segment. So we differentiate them by calling this the minor segments and the major segment. So it's very, very easy. Very, very easy. So the last but not the least term to know is the tangent. So the tangent is a line that touches the circle at exactly one point. This point is called the tangency. So this is a tangent. I'll be drawing it with a thick black ink. This is a tangent. This is another tangent. So it's just a straight line that touches the circle at one point. At exactly one point. So these are tangents. So we'll be using these tangents mostly in circle theorems. And that's where we're diving into right now in the next video. See you in the next video, guys, where we talk about the circle theorems. Thank you very much for watching, guys.